Remember that you are following the integration, what to do and when flowchart when answering integration questions. And also remember that you've got the formulae in the formula book to help you with integrating trigonometric functions. So question 13, we need to integrate tan squared x with respect to x. So let's look at our formula book here. We're looking for the integral of tan squared, and it's not there. We don't know what tan squared integrates to give. So now I'm thinking about a trigonometric identity that involves tan squared that will allow me to turn it into something that is here. And I know that tan squared can be turned into a sec squared. I know that tan squared plus 1 is equal to sec squared from my trigonometric identities. Therefore, I know tan squared can be turned into sec squared minus 1, which means I can then integrate the sec squared to be tan, and the 1 will integrate easily. So, turning the tan squared into a sec squared x minus 1. Sec squared integrates to be tan x, and the 1 will integrate to be x. So my answer is tan x minus x. Question 14. I'm first going to rewrite this with a negative power. Which will allow me to add 1 to the power. So minus 3 plus 1 is minus 2. We'll divide by the new power, so 8 divided by minus 2 is going to be minus 4. But we also need to divide by 2 because of the reverse chain rule, because of the 2x on the inside there. So divide by 2, and we get minus 4 divided by 2 is minus 2. And so that is my answer. I've got minus 2 lots of 2x minus 1 to the power of minus 2. Question 15. We've got the integral of f of x, which is 1 over x times 3x minus 1 squared. So we've got these two terms on the bottom there. We've got the x and the 3x minus 1 squared. I think we're going to have to do partial fractions here. I don't think there's going to be any quick way of rewriting this. Not that's helpful anyway. So let's do partial fractions. Let's rewrite this as 1 over a over x plus b over 3x minus 1 plus c over 3x minus 1 squared. Remember, you need the linear part and the squared part. Right, let's get a common denominator then, so that a is already over x, so it needs to be multiplied by the 3x minus 1 squared. The b is already over the 3x minus 1, so that needs to be multiplied by an x and another 3x minus 1. And the c is already over the 3x minus 1 squared, so that just needs to be multiplied by the x. So we've then got our common denominator, which is going to allow us to compare both sides. So now we've got a common denominator on both sides, we can just compare the numerators and find the values of a, b and c that are going to work. First of all, I'm going to let x be equal to 1/3. The reason I'm selecting 1/3 here is it's going to make this bit here become 0 and this bit here become 0. So the only part we need to worry about then is the c times 1/3 is equal to 1. So c is 3. So I can replace the c here with 3. And the c here with 3. Next, I'm going to let x be 0 now. The reason why I'm selecting x to be 0 is because it's going to make this term become 0 and this term become 0 because of the x in there. Which means that that's going to allow me to work out the a term. To get a times 3 times 0 minus 1 squared is equal to 1. So 3 times 0 squared minus 1. So 3 times 0 minus 1 squared is just going to be 1. So 1 times a is 1. So a is 1. So I can replace the a here with 1 and the a here with 1. Finally, we need to work out what b is going to be. And I'm going to do that by comparing coefficients of x squared. On the left-hand side, I would have a 3x times 3x, which is 9x squared, times 1. So that's a 9x squared. I would then have a bx times a 3x, which would be 3bx squared. And those are the only x squared terms I have on the left-hand side. On the right-hand side, well, there's just one. There's no x squareds at all. Oops. So on the right-hand side, we've got no x squareds. So just to recap, on the left-hand side, we've got 9x squareds plus 3b x squareds is equal to 0. So therefore, 3b will have to be minus 9 and b has to be minus 3. Which means I can now replace the b here and here with minus 3. So all of that work has allowed me to rewrite f of x as being 1 over x minus 3 over 3x minus 1 plus 3 over 3x minus 1 squared, which is going to allow me to do some integration now. The 1 over x is going to integrate nicely to be ln x. Then we've got minus 3 lots of the integral of 1 over 3x minus 1, so ln 3x minus 1. That's because of the reverse chain rule. I need to divide by 3 here. The 3 divided by 3 is just 1. And then we need to integrate the 3 over the 3x minus 1 squared. To do that, let me just rewrite that with a negative power. So that I can now add 1 to the power. So minus 2 plus 1 is minus 1. I would divide by the new power, so 3 divided by minus 1 is going to be minus 3. But then by the reverse chain rule, I also need to divide by 3 because of the inside there. So the 3 divided by the 3 is just 1. And so my answer is ln x minus ln 3x minus 1 minus the 3x minus 1 to the power of minus 1 plus c. Question 16. We want the integral of x e to the 4x. I'm going to do this by parts. So we want the integral of u v dash. Do remember you do have the integration by parts formula here. Oops. So we're going to select the u and the v appropriately. So I'm going to select the u to be the x, because that's going to differentiate nicely, and the v dash to be e to the 4x. So differentiating the x, I get 1. Integrating the e to the 4x, I'll get 1/4 e to the 4x. Applying the by parts formula now then, we've got u times v minus the integral of u dash times v. So our answer is 1/4 x e to the 4x minus, now integrating the 1/4 e to the 4x will be 1/16 e to the 4x, because the exponential will integrate to be the exponential, and I've divided by 4 because of the reverse chain rule. So the 1/4 became 1/16. Question 17. Figure 1 shows a sketch of part of the curve with the equation y equals x over 1 plus root x. We need to find out the area of R bounded by 1 and 4 using substitution. So we want to do the integral from 1 to 4 of x over 1 plus root x with respect to x. That calculation there is going to give me the area of R. We're told to use the substitution u equals 1 plus root x. So I first want to do some differentiation on that because I need to change my dx into a du. Now I could differentiate it the way it's written straight away, but I don't like that square root. So I'm going to subtract 1 from both sides and square both sides just so I can differentiate without the square root. You don't have to do that. You could differentiate this straight away, but just from experience I know that when we do that, the square root becomes quite nasty in terms of rearranging. So I'm not going to do that. I've rearranged to make x the subject, so now I can differentiate that with respect to u. Times by the 2. Take 1 away from the power. So I can now say that dx is equal to 2u minus 1 du. And I can plug that instead of the dx here. Whilst we're at it, let's also change those limits. So when x is 1, u is equal to 1 plus the square root of 1, which is 2. When x is 4, u is equal to 1 plus the square root of 4, which is 3. So we're going to swap the 1 here for a 2, and we're going to swap the 4 here for a 3. Right, the x in the u world is u minus 1 squared. The 1 plus root x in the u world is just u. And the dx has been replaced with the 2 lots of the u minus 1 du. Right. Just simplifying everything that we have there. We've got the u minus 1 squared times u minus 1, which is u minus 1 cubed. And we have 2 of those. We can now expand out those brackets because we're going to need to divide each of the terms by the u from the denominator. So expanding those brackets, we've got u cubed minus 3 lots of u squared plus 3 lots of u minus 1 all over u. This is just me expanding this. Multiply all of that by 2. So 2u cubed minus 6u squared plus 6u minus 2, dividing each of those terms by u. to get the integral of 2u squared minus 6u plus 6 minus 2 over u du. Right, let's integrate each of those terms and then look at our limits. The 2u squared will integrate to be 2/3 u cubed. The 6u will integrate to be 3u squared. The 6 will integrate to be 6u. And the minus 2 over u will integrate to be minus 2 ln u. Substituting the 3 in, then substituting the 2 in, and right, let's go through each of these terms and simplify it. The 3 cubed is 27, divided by 3 is 9, times by the 2 is 18. Three squared is 9, times 3 is 27. 6 times 3 is 18. And we'll leave the minus 2 ln 3 for now. Second bracket, the 2 cubed is 8 times 2 is 16, so we'll get 16 over 3. Two squared is 4 times the 3 is 12. Plus the 12, plus the 6 times 2 here is 12. And again, we'll leave the logarithm where it is there for now. I can see the minus 12 and the plus 12 there. They're going to cancel out. The 18 minus 27 plus 18 is 9. Oops. Right. Just being careful with these brackets now then. We've got 9 minus 2 ln 3 minus 16 over 3 minus minus, so a plus 2 ln 2. The 9 minus the 16, let me get myself a bit more room. The 9 minus the 16 over 3 is going to be 11 over 3. And just to help me simplify these logarithms, I might rewrite them so the positive one is at the front. So a positive 2 ln 2 minus 2 ln 3. And so now it's clear that with the minus here, I can use the division law, so I'll get 2 over 3. The 2 over the 3. And there we go. That is the exact area of R.